Every one of these solar panels started as this: ordinary sand. Here's how. First, we need quartz. Lots of it. Quartz is mined from the earth, crushed into smaller pieces, and prepared for one of the hottest industrial processes on the planet. Right now, it's just rock. Not a solar panel, not even silicon. Inside giant electric furnaces, quartz is heated to more than 2,000 degrees Celsius. The rock begins to glow, then melt. Oxygen is removed. Silicon remains. But it still isn't pure enough. Again and again and again. It is refined until almost nothing remains except ultra-pure silicon, one of the purest materials humans can make.
The silicon is melted once more. A tiny seed crystal touches the liquid surface. Slowly, it rises. Atom by atom, a perfect crystal begins to grow. This process can take days. When it is finished, the crystal is massive, sometimes taller than a person. This single crystal will become thousands of solar cells. Next, the crystal is sliced. Diamond wires thinner than a human hair cut it into ultra-thin discs called wafers. Each wafer is polished until it becomes almost mirror smooth. Every scratch matters. Every particle matters. This wafer is now the blank canvas of a solar cell. Inside a clean room, the wafer begins to change. Special elements are added. A microscopic electric field forms inside the silicon. A blue anti-reflective coating is applied to capture more sunlight. Fine silver lines are printed across the surface. These lines will carry electricity away from the cell. Now, something extraordinary has happened. This thin blue square can turn sunlight directly into electricity. One solar cell is useful. Dozens are powerful. The cells are connected together, sealed beneath tough protective glass, enclosed in weatherproof layers, and locked inside a strong aluminum frame. Heat and pressure fuse everything into a single unit. The transformation is complete. Sand has become a solar panel. Before it leaves the factory, the panel is tested. Bright lamps imitate years of sunlight. Machines measure electrical output. Heat, moisture, wind, and stress are simulated. Only panels that pass every test continue their journey. Weeks later, that panel may be installed on a rooftop, or in a school, or beside a hospital, or across a desert solar farm stretching to the horizon. Sunlight strikes the cells. Electrons begin to move. Electricity flows. Quietly. Continuously. For decades. A grain of sand. A crystal. A wafer. A solar cell. A solar panel. Electricity for the world. The next time you see sunlight shining on a solar panel, remember, the journey began with a handful of ordinary sand.